Hello everyone, myself Marisa Sawant. I am from Vidyadeep Institute of Engineering and Technology. In last lecture, we learned about analytic function. What is analytic function and the necessary conditions for the analytic function. That means we learned Cauchy-Riemann theorem, means CR equations. Today we are going to see the examples related to analytic function. In last lecture, we learned about analytic function, Cauchy-Riemann's equation, necessary and sufficient conditions for the analytic, Cauchy-Riemann's equations in polar form. Today we are going to see some examples. First example is write the function f of z is equal to z plus 1 upon z in form of f of z is equal to u of r theta plus I into v of r theta. Okay, we are first step is we write f of z is equal to z plus 1 upon z, which is given in question. Then we consider z is equal to r into e raised to I theta, which is exponential form of complex number. Then we put value of z in f of z. Okay, we put the value of z in f of z. Then we get r into e raised to I theta plus 1 upon r into e raised to I theta. Okay, next step is we write e raised to r into e raised to I theta as it is, as above, plus second term we have 1 upon r into e raised to I theta. We take e raised to I theta in numerator. That's why here 1 upon e raised to I theta, we have e raised to 1 upon e raised to I theta. We take e raised to I theta in numerator. Then it becomes e raised to minus I theta. Remember that if a power of any number in denominator is positive, numerator or denominator is positive, if we take the number in a numerator or in denominator, power will be changed. Okay, it means if it is positive, it becomes negative. If negative, then positive. Okay. Next step is then we put the we are going to use Euler's formula. Our Euler's formula is e raised to I theta. Euler formula is e raised to I theta is equal to cos theta plus cos Euler's formula is e raised to I theta. This is our Euler's. We are going to use Euler's formula. Euler's formula is e raised to I theta is equal to cos theta plus I sin theta, and second is e raised to minus I theta is equal to cos theta minus I sin theta. We are using the both Euler's formula here. Okay. The next step will be r into cos theta plus I sin theta plus 1 upon r cos theta minus I sin theta. Okay, we are taking next step will be we write in form of we write real part and imaginary part separately. then we get r plus 1 upon r and cos theta as a we take r plus we get r plus 1 upon r and cos theta is common in both the term, that's why cos theta is common. Then second is our imaginary part will be I common, then r minus 1 upon r sin theta. Okay, next step is it will be our this f of z is in form of r and theta, which is required in our equation. Okay. Next example is show that f of z is equal to z cube is analytic everywhere. Okay, we are given here f of z is equal to z cube. Then f of z is equal, we know that complex function f of z is equal to u plus iv, and complex number z is equal to x plus I y. Okay, then we put the value of f of z is equal to u plus iv and z cube is equal to x plus I y cube here. Okay, f of z is equal to u plus iv and z cube is equal to x plus iy all cube. Okay, then we put the we are using the formula for a plus b all cube here. Okay, formula for a plus b cube, b all cube is equal to a cube plus b cube plus 3a square b plus 3ab square. Okay, then the next step will be x cube plus iy cube plus 3x square iy plus 3x iy square. Okay, in next step we are writing x cube as it is minus the value of I cube. The value of I cube is equal to minus I. Okay, we are putting value of I cube is equal to minus I, and y cube as it is plus I 3x square y minus 3x y square. We put the value of I square is equal to minus 1 in last term. Okay, next step is we are going to separate the real and imaginary part. Then we get x cube minus 3x y square plus I common, right, imaginary part 3x square y minus y cube. Okay, now comparing real and imaginary part, u is our x cube minus 3x square xy cube square and v is 3x square y minus y cube. Okay, now for analytic function it is condition that we have to the conditions of CR equations are satisfied, and CR equations are del u by del x is equal to del v by del y, and del u by del y is equal to minus del v by del x. This is the equations of CR equations. We already learned in last lecture. If you have a query, you can go through last lecture's video, means part 6 video. Okay. Now ahead, u is equal to, we have u is equal to x cube minus 3xy square. Therefore, we take the partial derivative with respect to x. Then we get del u by del x is equal to the derivative of x cube is 3x square, and derivative of 3xy square is equal to 3y square, means 3y square is constant and derivative of x is 1. Okay, whenever we have to do partial derivative, it means with respect to one variable, the other variables are considered as constants. Okay, that's why del u by del x is equal to 3x square minus 3y square. Okay, similarly we find del u by del y. Del u by del y is minus 3 6, the derivative of 3x square. Okay, derivative of 3x square is minus 6xy. Okay, now derivative del u by del y. Okay, x cube, the derivative of x cube. Here we have to do derivative of u with respect to y. It means x, consider x as constant. Then the derivative of x cube is 0. The derivative of minus 3xy square. Okay, minus 3x is constant, and the derivative of y square is 2y. That's why we get here minus 6xy. Okay, similarly we have given v is equal to 3x square y minus y cube. The derivative of v with respect to x is del v by del x is equal to 6xy, and del v by del y is equal to 3x square minus 3y square. Here we can see that del u by del x and is equal to del v by del y, and del u by del y is equal to minus del v by del x. Okay, we can see here. So CR equations are satisfied. Hence f of z is analytic everywhere. Now we stop here for today's lecture. Further in next lecture we are going to learn harmonic function. Today we stop here. Thank you for attending and watch this video. Thank you.